DJ taught me how to. Okay, where did it go? I saved it. Alright, I know where it went. It went here, not here. Okay, close that one. Went into. No, not that one. Yes. No. Where the heck did it go? There you go. I just don't want to write it. Why did you start CAD for me, DJ? Must have clicked CAD. I just don't want to write them again. Not here. Okay. Close this one. No. Minimize this one. Close this one. Close this one. Close it. Okay. That's fine with me. Not here. All right, well.
Three types.
Three types. Okay, whoever need it, guys.
Sorry, said the emergency system.
Emergency number one is emergency system.
Legally required.
And number two, legally required. And number three, thank you, optional standby. Okay, option standby, and we said this one, the first thing is the article is 700, right?
Yes.
The second one here is 701, and the third one here is 702. And the second thing, guys, what did we say about this one? It comes within 10 seconds, and we said is isolation. Isolation. What I mean about isolation, what I mean about isolation, guys, the branch circuits and the feeders must be completely isolated from any other power system. Okay, Brooks? Complete isolation for the emergency system from any other system. So these are 710 seconds isolation from any other system. Isolation from any other system. So these are the major topic for that one. Let's go to the legally required system now. Yeah, where it's required. It's required mostly for life safety. Mostly it's required, guys, for anything that depends on life safety. For example, emergency lights. If you have an area, you have to have an emergency lights in case of loss of power. You need people to exit the building safely. Exit the building safely. When we went to hospital, if you guys remember, in the hospital, the ones who were in my class, we sit in the hospital in the bed area, the patient bed area. They have a dedicated receptacles that will be energized momentarily within 10 seconds in case of a failure of fire, a failure of power. So life safety, anything related to life safety. Most of the time, guys, most of the time, we only talk about lights. In hospitals, they add receptacles and they add heating, cooling system for the for the operation room and so forth. So that's life safety. The second one, legally required 10 seconds. 60 seconds. For the legally required system, guys, you need it to be legal 60 seconds. The same thing. The power will come within 60 seconds and designated. So this is 60 seconds. It has to come. And legally required system, no isolation.
What do you mean by isolation?
Isolation means the branch circuits of the power and the branch circuits, all branch circuits of the emergency system have to be completely isolated from the branch circuits of any other system.
So how do they switch it? Is it only outlets only on that system?
Yeah, you have a EMP conduit feeding this receptacle coming all the way. The EMP, nothing inside it except the ground circuit that feeds the receptacle all the way to the emergency panel. And then they have a transfer switch that transfer between the emergency generator source and the emergency generator panel. These guys, and so 70, 60, no isolation. The third one, guys, is government. Basically, authority having jurisdiction. I want to add authority having jurisdiction. Now, you're going to ask me what type of loads are going to be legally required. For a 911 calling system, you can put certain loads as legally required by law. But who decided if it's really, if this receptacle is going to be required to have power within 60 seconds? The authority having jurisdiction, a government agency in the area decided, and in case of a fire, in case of an emergency, I want all the receptacle in a 911 calling system to be energized. These are not people's life. We can argue. In the building, the emergency, it's not, people's life is not dependent on them being here in that building, but they're really required to be hot within 60 seconds. So if you guys think, if the way I think about legally required is the emergency is right here in terms of important, and the legally required is the second step in the emergency system. So you have your emergency system within 10 seconds, then these loads are very, very, very critical and important, but they're not emergency. Optional system, whenever. Optional system, guys, time-wise, whenever you decided to switch it. In terms of isolation, no isolation. And in terms of who decided, owner. Who decided that I need an optional system? The owner. Dunwoody College of Technology, a good example. Do we need to pick up, if we lose power, Brad, do I need to pick up every single outlet in your area? From this, the outlets right in front of you guys, right in front of you. Do I need to pick them up? Are they emergency system? No. Are they legally required system? You're not doing very important things for the government or for the state or whatever. No. So what would they be then? Optional. I want to pick up the loads, optional. These are really the most important thing, guys, to understand about these three systems. These three systems. There's a couple of other systems related to, but any question about that? Now, all these three systems, Spencer, they need a power. They need power source. All of them need power source. And that will bring us to our topic for today. Really, our topic is not these. Our topic, we're going to talk about these guys in details later on. Our topic is the power sources. Power sources for all these systems. Any question, guys? Any question about these? But when I say I have a generator, Brooks, when I say I have a generator, you're going to ask me, Chad, is this generator feeding an emergency system? So I need to crank this boy and bring it up to speed within 10 seconds? Or is it feeding a legally required system, so I have to bring it up and running and stable within 60 seconds? Or is it feeding an optional system with whenever Jeff Keljic finishes his coffee, goes crank that transfer switch and start that generator? So these are the things the reason why I put them on the screen, guys, to get you to think that all these generators can do one of these functions or all. I can have one generator. I want you guys to, I can have one generator that can feed all these systems together. So let me just draw a power system. Here's a generator. Here's one load, another load, a third load. And let me tell you how, if you can imagine, transfer switch coming in from here, another transfer switch, a third transfer switch. And these transfer switches are feeding, I have a generator, I have a big generator here, is my gen. And my generator has coming to a different sections. So from one section, I feed this one. From the other section, I feed this one. From the third section, I feed. Can you guys see these are auto transfer switches? And then from the auto transfer switch, the first one is going to be emergency. So I'm going to grab the emergency and go all the way and feed the emergency. The second one would be legally required. I'm going to grab and go feed the legally required. The third one is going to be optional. So you have a power system, say this one a 4,000 amp service coming and feeding auto transfer switch dash 1, auto transfer switch dash 2, auto transfer switch dash 3. And these are generator. This is, let's just say this was a 2,000 amp switch gear. So we have two sources of power, guys. Here's a utility coming in. Here's a generator coming from this side, the red. I have a switch gear where the generators are feeding. And then from the switch gear, I'm taking a feeder to auto transfer switch 1, 2, and 3. And each one of these transfer switch 1 feed emergency, 2 feed legally required, and 3 feed optional. Optional system. That's as complicated, honestly, as you're going to encounter when you have a generator. The same generator is feeding legally through different auto transfer switches, feeding emergency system, legally required system, and optional system. We will leave, guys, the details to later in terms of that. Now, this book, Spencer concentrates on only one system at a time. But you can think of all these systems could be grouped together. Any question, guys, about that? So we have 3 systems. We either can feed them from 3 different generators. I can feed them from 3 different generators, or I can group one generator through a switch gear, feed these through auto transfer switches to each one of these systems. For example, Brad, the auto transfer switch number 1 has to transfer within 10 seconds. So the first thing you energize that generator, within 10 seconds, it will energize, the auto transfer switch will pick up. Then the second auto transfer switch to pick is what? Within 60 seconds. After that, the auto transfer switch, and you guys can delay them. These have delay on them. You can delay this one after 10 seconds start. Then when everything is up, this, guys, you can tell this one after 60 seconds start, and you can delay that. So then you transfer these within 10 seconds. Now up the stable, everything is okay. Now this guy is not yet transferred. Now the 10 seconds are done. This is energized. This will energize. After 60 seconds, I can energize that one. So that's how you group them all together in one system. Any question, guys, about that? Any question, Mr. Bab? So that's basically the ultimate solution that you're going to be doing. I'm going to go, guys, directly into there's a few things about the safety, guys, when you have a generators. As I said, this chapter mainly about the power source, not the systems. The systems, we'll talk about them mainly. If you have a power source, which in reality is going to be a generator, they have a couple of things, guys, to do. Generator, always turn off the power when hooking a standby system. If you don't have, let's go back here. There you go. If you don't have an auto transfer switch, guys, like this, when you have an auto transfer switch, there's no chance for any mistakes because the auto transfer switch does the transfer for you. Nobody's turning anything on and off. The worst thing that could happen to you, Brad, is you have the generator running and at the same time the utility running, and the generator and the utility are tied together if they're not in sync. You will do 2 things. You blow up your generator, or if the utility is de-energized here, there's no power on the transmission line, you will actually power the transmission line and kill one of the linemen there. Right? So imagine if these are tied together and I'm generating here and I'm feeding my loads, okay, that's how it should be, and at the same time feeding power back into the system. You can kill one of the transmission line, guys. The transfer switch, either normal and completely isolated from the emergency system, the generator, or generator and you're completely isolated from the power source.
What does it do when it shuts down? Does it does it recognize power coming in?
Yeah, very good point. The auto transfer switch have brain, guys. There's electronics in it. When the power comes back, the first thing when when you lose the power, the first thing happens if you lose the 4,000 amp switchgear completely dead, right? We lost it. The first thing happens is the auto transfer switch has some batteries on it that they can sense that there's no power coming in. There's no power coming in at this point. So what do? They send a signal to the generator. The auto transfer switch will send a signal to the generator to start the generator because the generator will be dead. Send a signal to start the generator. Now the generator is up and running. The generator is up and energized this switchgear. Up to this point, this switchgear is energized. The power is right up to the switch, to the auto transfer switch, but we haven't transferred yet. Then within 10 seconds, this auto transfer switch will close, energizing the emergency system. Now my emergency system is up and running. Then after 10 seconds, 15 seconds, 20 seconds, 25 seconds, up to 60 seconds, within that range, this guy wakes up, you're adjusting it, and energize, close. When I say energize, guys, shift, close. Now the legally required system is up and running within 60 seconds. From 10 to 60 seconds, that's a range, 10 to 60 seconds, anytime in between. 10, why 10? Because we need to allow the emergency system to energize. From 10 to 60 seconds, energize the legally required system. After that, one second, after 60 seconds, why? Because now these two systems are up and running and cool and nice. Then this auto transfer switch, you can put it another like a minute and a half. Anything after 60 seconds, you can set it up to transfer, or you can wait in an hour if you want. There's no limit. Yes, sir.
The emergency systems or whatever, are those, like, let's say power goes out and then it switches over, right?
Within 10 seconds.
That instant?
Within 10 seconds.
Within 10 seconds, isn't there people that would die in hospitals that went on?
Well, the life safety stuff, they have their own batteries, the equipment. Like if their chest is open, yeah, if their chest is open, and the generator will come within 10 seconds, but the machine that open your chest has its own battery backup, at least for the first 10 seconds. Then you back him up with 10 seconds.
Well, you said that the second, third one going to have to be isolated, but if the first one recognizes it and shuts down, is it going to backfeed the system, or no? Because it would be
Isolated.
well,
You're working right in here. The transfer switch is working right in here, guys. My transfer switch is working right in here. So you have control over which and when to shift from one source of power to the other. You have control by adjusting it.
So then what were you saying about the fact that it could have possibly
Ah.
backfed the system?
Thank you. What happened is, if you don't have an auto transfer switch,
Oh,
and you decided, I have an example here, guys. You decided to go bring your generator here. A lot of people, guys, bring a portable generator, plug it into the outlet. Completely legal. Bring a portable generator, plug it into one outlet. Now, from one outlet, you energize, and they come to the main here. They shut the main down. Now, right? Now, you isolate yourself from the utility. You shut the main down. Now, everything here is hot. Two problems. Number one is, if you energize the whole panel, then everything in the panel will be taking power from this outlet. This outlet is what? 20 amps. Now your dryer is going to be taking outlet from, if it's a house, of course, you have a dryer, you have a range, you have everything. It's taking all the power through 20 amps. You're going to burn it, number one. Your generator will shut down immediately because it doesn't have enough juice to feed this one. Number two is, accidentally somebody closed the circuit breaker. Now guess what? Not only you're feeding your panels and your load in the house, you're actually transforming the 240 power, or 120 in this case, 120 power all the way to 13,800 volt on the transmission line. Because the power goes up, down through the transformer, all the way to the transmission line. And if the transmission line people are working on the transmission line to fix them, you burn somebody. So that's why they don't want you to do that one. They don't want you to plug it into an outlet. A lot of people do that though, in residential. They plug it into an outlet, energize the house. You're not supposed to. I'll show you the alternative for this. I'll show you guys the alternative for this. We'll show the alternative. But before we go into the alternative, let me just go about the safety, guys. when you talk about generators, you always, as we said, always turn off the power when hooking up the standby system. That's a manual hookup, not auto transfer switch. Operate generator only outside. As you guys know, generator burn natural gas or burn diesel or burn some type of, and of course you don't want to burn this one inside your house and have carbon monoxide and burn yourself. Store gasoline in properly located places. These are all
You're talking about turning the power off the service coming
of the main, yeah, before you hook up your generator. So these guys, there's a couple of things in page 628 in the book. Do not stand in water or otherwise work on electrical equipment with wet hands, and all these are safety stuff. You guys will read them on your own, mainly for electricians and install. Always follow manufacturer instructions. The intention of the standby power system, guys, is to get you to, let's go back into, is to get you power in case you lost your own power. Let's just go this one. This is now we have 3 types of emergency system: legally required and standby. This pump, if it's a sump pump in your house, is this emergency system as far as the code concerned? No. Who cares if you flood your house? Is this a legally required system? It is, probably, if it was a government building and you don't want to flood the government building. In your house, no. So what system would that be, guys, to plug in just to pick up? Optional system. So we decided it could be anything, but in this case, option system. The cheapest, easiest standby system you buy as you buy a generator, standalone generator, and you plug your equipment directly into the generator. So the generators that you guys buy, portable generators, they have these portable generators. Portable generators. They have 220 amp at 120 volt, and they also have 20 amp at, some of them at 240 volt. So the generator 240. So you can plug in, grab your equipment here, and plug it directly into the 240. And if the generator is sized right, your generator should be able to pick up this equipment. That's the cheapest, easiest way of picking up a load. The easiest, cheapest way of picking up a load.
So would they be like kind of considered like maybe they should be able to handle, 80% of the load?
Sizing them.
Like each output.
Sizing your load. We're coming. When you size, how do I size this generator? How do I size this generator, guys, to pick up this pump? Just simple. One pump, one generator. If this pump was 5 horsepower. And so you have 5 horsepower, then you need your generator to be able to pick up 5 horsepower at 240. So what's the full load current for 5 horsepower at 240? What's the 5 horsepower at 240? 17? Sounds like 17, no. Single 240. 28 times 240. Okay? 28 times 240. And because it's continuous load, it could be continuous load running. What do you do? What do you add to it? 1.25. What do you guys come up with? 8,400. 8,400 volt amp. 8,400 volt amp. So your generator here, if it's only to pick up this load, guys, if it's only to pick up this load, did they say something? Say, 84. Sorry, 8,400, not 34, Chad. Volt amp. If your generator is to pick up this load, then minimum generator that you need here is what? 8,400 volt amp. This is running load. Sizing based on the running load. If you have another pump, guys, what do you do for another pump? Find the volt amp, add it to it. Add the other volt amp. If you have a couple of lights to add to it, add the volt amp of the lights to it and size the generator.
They size your bullets accordingly. So that
You
they
choose,
will
you
be
choose,
per command.
yeah, like we size any system. You choose the continuous load, multiply by 1.25, everything else added to it. Everything else added to it. Any question guys about running load? Yes, sir.
You know, I have 2 days without electricity in my home since Saturday and Sunday. And some of the neighbors, they said the transformer was blown out. So one house couldn't be set. Some of the houses, when I went back, they have got a light. And then I said, how come I don't have a light? They have a generator.
They have a generator.
Yeah,
Yeah.
silent. And I would probably get if I know the price of the generator at that time.
Yeah.
Because the kids were suffering, was fixing the call. But I didn't know how to connect it. So in this case, you need that you can switch off buy the generator.
Mr. Beb, if you want a generator for your house, hold your horses. I'll show you exactly how to connect it. The second
All right,
slide.
thank you, sir.
Next slide.
Yeah, thank you.
Exactly how to connect it.
Yeah, all right.
This is just, guys, a portable generator, a one load deal, plug it in. The cheapest, easiest, not a house. One load, plug it in. One load, plug it in. So, as long as, another thing, guys, for the generator is that you have to pay attention to when we size them, any generator, not just this one. So this generator is going to be minimum of 8,400. Then you're going to go, guys, to Cummins, any one of these manufacturers, buy yourself a generator that has this amount or higher, obviously. The second sizing is starting load. We size generator based on 2 things. Number 1, running load. Number 2, starting load. Now starting load, let's assume this pump, guys, that I gave you, this 5 horsepower pump, the code letter for it, let's assume the code letter for this pump, code letter given for this pump was L, code L. Let's assume the code letter for this code is code L, okay? Can we find the starting current of this pump? Which table are we going to go to? 300, 430 something. If you guys go to 430.7b, if you go to 430.7b, are you guys there? Table. If you go to table 430.7b, 430.7b, my design L is 9.99. Are you guys there? This is page 313 in the new code book, 430.7b, 430.7b. Okay, 430.7b, my friends, give you I start. I start equal 9.99 times, what's the horsepower, Holly, of this motor? 5 horsepower. Divide this by, multiply by 1,000, because always in the formula by 1,000, divided by what's the voltage system? 240. What we're doing, guys, is we're sizing the generators. We're sizing the generator based on 2 sizes. Number 1 is the starting capability of the generator, and number 2 is the running capability of the generator. The starting capability and the running capability. Anybody has a calculator handy? 208. 208. What's the starting current? This is 28. 208. Anybody came up with something different? 208. 208. 208. Okay, and this is the starting current. Now the starting KVA, guys, KVA start, you take the 208 and multiply it by what? I guess you could have done it, taken it from the beginning. Take the 208 multiplied by 240. We could have done it here, guys. 28 times 240. Anybody has a calculator handy? 28 times 240. How much? 49,900. Volt 10, right? Right? Red, 49,900. Okay, now with this, with these two sizes, guys, then you go to Cummins and you tell them, I need a generator that will be able to run continuously an 8400 volt amp and start momentarily almost 50 kVA, almost 50 kVA.
That's in rush, right?
That's an inrush. Start 50 kVA. Very, very important, guys. There are two sizes for every generator. Next quarter, I don't want to spend too much time on it. Next quarter, we'll have two generator softwares. The two generator softwares, Mr. Irbab, will be walking you through two sizes. If you're understanding it now, you're done next quarter. Two sizes. Number one, you need to size based on the volt amp, the starting current, which is piece of cake. Convert the horsepower into what? Into watts. The second size is you need to size it based on the inrush of the motor. The worst thing that could happen, guys, is if you have a pump here that the generator is not able, because it's not robust, it's not good enough, it's not able to start. It will be able to run it, no problem running it, but it can't start it. So how are you going to run it if you can't start it? Unless you have a mechanical coupling where you run it first and then you transfer it running into, it will cost you an arm and leg to transfer the load running into the generator. So in this case, guys, my generator, my friends, my gen that I need to buy here, my gen is going to have 8.4 kW or kVA, and we'll get into the difference, guys, and also close to 50 kVA. Two sizes. This will be run, this will be start. So when you go buy a generator, you're going to have two sizes for the generator. One, I need my gen to be able to start a 50 kVA and run an 8.4 kVA.
So it's just a 50 kVA wouldn't be good enough?
A 50 kVA would not be good enough?
No, would that be good enough?
50 kVA?
Yeah.
Yes, for this load. 50 kVA start.
But it has to
Only for
idle
10
and
seconds.
run.
Only for 10 seconds. Oh, guys, a 50 kVA here is only for 10 seconds. Start is only for 10 seconds. Run is forever. Start is for 10 seconds. Run forever.
So it has to maintain an 8.4 after.
Yes, thank you. At the first 10 seconds, my generator can be loaded up to 50 kVA. After 10 seconds, the voltage and the current will go down all the way to what? To 8.4 kVA. So, and if you guys, as long as you brought me to this, I want you guys in your book to go to page, please. Go to page 638. 638. In 638, this book. In this book, 638, guys, there are two types of loads for equipment. If you guys look at the blender, this is residential, so if you don't see anything big, don't worry, it's residential. Typical operating voltage required to operate is 600. That's running. Spencer, that's running. How about starting wattage requirement? What's the starting? That's the ability to start it. It takes another 100 watt, 14 seconds, only 14 seconds. Then it dips down to 600. So keep going, guys. All these coffee maker, these are suggested values all the way to furnace. Look at the furnace half. Look at the furnace half horsepower. The furnace, because it's a motor, guys, half horsepower. To run it, it needs 875. But to start that boy, it's 2650. 2650 to start it. Toaster and all this good stuff. Now, if I ask you to go size me a generator to pick up all these loads, to transfer all these loads. Two things you need to do. Number one, you need to add all these running KVA, all of them. So just all of them. Pick up, so you add all the volt amp. That will be your starting, your running KVA. The second one, you're going to add all these starting KVAs or VAs, and that will be the starting capability. And you come up with 2 volt amps, one start, one running. When you talk to one of the manufacturers, they're going to ask you about the same thing. They're going to ask you, what's your starting capability of this transfer switch, and what's your running capability? If you give them the running only, guys, it's meaningless because you need to be able to run them and start them and run it. Unless Holly, you decided to start them not at the same time, and you have control over that. What they do, guys, to reduce, how can you, there's no way you can reduce this value here. The running capability, there is no way you can reduce it unless you turn a load off. But turning the load off that you need is not a good idea. I need a light, and to reduce the load, I turn the light off. That's an option. But how can you reduce the starting capability of a motor, of a generator, or load, the load that you have, the starting capability? Thank you, time delay. Instead of starting them all at the same time, guys, and that's what we're going to be doing in commercial industrial. Instead of slamming a 4,000 amp load from the utility down into the generator and bringing the generator down to a halt and stop completely, what they do, you take the 4,000 amp load and chunk it in chunks of loads. So they say, okay, instead of slamming the whole 4,000 amp load, we're going to take the first 500 amp and transfer them. Now, the only inrush that the generator has to be able to handle is just for the first 500 amp. Transfer it within 10 seconds, up on speed, running. Now, it goes all the way up, it goes down within 10 seconds, now we're stable. Go to step 2. Take the second 500 amp. Transfer it again. Now the generator is not going to see, it's only going to see the inrush of 500 amps at one time.
Plus the main.
Plus, thank you, plus the load, the 500 amp load. For high 500 amps, we will be able to see it, but not the inrush of the 500 amp. The 500 amp load is here, the inrush of the 500 amp is here. So by doing that, guys, they reduce the inrush of the load. By reducing the inrush of the load, they reduce the size, the physical, mechanical size of the generator. Otherwise, if you want to pick up the whole building all at once, at one time, in one slam, you would not find a 4,000 amp, you would not find even multiple generators who would be able to pick it up at one time. What they do is they stagger them. Start step 1, step 2, and every step, 10 seconds. Why 10 seconds, guys? Typically, generators and motors within 10 seconds, it could be 5 seconds, within 10 seconds, they come up to destabilize and they go all the way up and it goes down.
Just like a TOD, just their standard time on delay.
Time on delay on the generator, yeah, you delay them. You delay the transfer switches for, you stagger them. The first load, the first 500 will start at 10 seconds, then 20 seconds, 30 seconds, 40 seconds, 50 seconds, and so forth. Any question, guys, about reducing the inrush when you size a generator? Yes, Mr. Bev? 9.99. 9.99, this number, Mr. Bev, came from this table based on this code letter. I'm giving you that the code letter of this particular load given, could be any load, is L. And if you go to table 430.7b, it will tell you that the worst scenario is 9.99. Did we do it right? 9.99.
So you're looking 5 horsepower and give you that.
Yes. You're looking at the L. If you look at L in the table, right in that table, go all the way to the L, you find the 9.99. Any question? I can't emphasize, guys, when you size generator, you size in best. I can't emphasize this one because next quarter, you're going to have softwares. You're not going to do it by hand. We're going to have a software, and the software is going to ask you what's the horsepower of the motor. You put the horsepower, what's the voltage, what's the power factor, and based on the horsepower, the voltage, the power factor, and the code letter of the motor. The code letter of a motor, the software will calculate 2 values. Calculate the starting current of the inrush of these motors, as well as the running volt amp.
I got a question. So on the chart where you're taking off the L, the code letter, you go to the highest number, because it's 9 to 9.99.
That's worst case scenario.
Okay,
Unless you know otherwise.
okay.
Unless in the manufacturing document says no, go to the lower. Your worst scenario would be the 999. Any question guys about sizing? So we know that's the cheapest piece of equipment they're going to buy. Plug it in. All these have to be GFCI'd. All of them on the portable generator have to be GFCI'd. So your equipment have to be GFCI compatible, or it's not going to be able to run on these. I can't emphasize, guys, two things: sizing generator based on running load and starting load. Any question about that one? Any question about that one? And I promise you, next time we will not be doing it by hand. We don't have a generator for this building, guys. But if you want to size the generator right now, no problem. Go based on the load, not based on 500 amp. Remember the 500 amp panel? The worst that could happen to you is to go, I have a 500 amp panel, I'm going to size a 500 amp load generator. Bad idea, oversized. You're going to go down to the load, actual load. And my actual load in reality came up to 420. I can size my generator for 420, not the panels. The panels we went up because of future expansion and blah, 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 and so forth. And we couldn't find the size of a panel, so we went to the next size up. You size based on the actual load. Any questions about that? Running, start, run, start, run, start. Okay, so that's the cheapest piece of equipment that you can buy. The cheapest piece of equipment. You guys want a break before I go over that? 5 minutes break. We'll go over that one. Mr. Rebab, this is what you want to do in your house.
Yeah, thank you.
That's exactly what you want to do.
I need to know that because it was there for that.
Except, yeah,
Chad, what is locked rotor?
it's an inrush. Start.
inrush.
All, yeah.
Well,
Locked
I
rotor,
can always get that.
Yeah.
confused.
inrush, starting current, locked rotor
Oh,
current,
just-
all the same.
Alright.
Don't some of them big motors take like 8 hours to get going,
8 hours too.
to get going to full speed?
When you say motors, you mean generators or motors?
Huh? The one that Chuck used to tell us about motors that would take the whole day to get going to full speed. If you shut them off, they take a full day to get them going again. Because just the stator alone was like 40 tons, we'd say, on them.
You need to energize. There's a huge, I mean,
Well, he works for a company like Hero and like he redid the generator, rewound the generators for Ford plant. Like he was doing monster motors. They'd have semi.
any question, guys, about this? We will talk a little bit more about the separately derived system, but this is really the main thing. If you want to understand it, do we bond the neutral in a separately derived system? Yes. Do we switch the bond the neutral to the ground? Yes. Do we switch the neutral? Yes. In a non-separately derived system, do we do that? No. Do we bond? No. Do we switch the neutral? No. These are really, Holly, the main difference between separately derived system and non-separately derived system. So looking at this, guys, Mr. Rebeb, this would be a non-separately derived system. If you want to do it in your house, that's the most common. You guys, a lot of manufacturers sell this box here. You buy this box, you buy, and then the plug, and then you just wire it. The only thing, and the generator, the plug, and the box you have to buy them, special box, and the rest is just wires in between them. And then cable, you should be able to wire.
But anyway, my panel, it cannot be.
But you have to change into fuse. Okay, this is the next important one, guys. Here, let me close this. Okay, now this is just to give you an idea, guys. Normally, if you can you look at normally the same application. Normally the power is coming from this 40 amp and energizing this sub panel. Normally this acts as a sub panel. This acts as a sub panel feeding multiple loads normally. Now when I lose power, look what happened. When you lose power, you're gonna go switch. The first thing, and I'm gonna let it go. The first thing you're gonna go is obviously isolate. Well, you don't even need to isolate that one. Just isolate, flip this circuit breaker to close the generator and start your generator. One thing you need to do, two things. Number one, you start your generator, and number two, you go to the circuit breaker, turn it on to the generator and off from the utility. It will be utility on, generator off, and when you lose power, you go with one mechanical physical movement, transfer the utility off and the generator on using this specially designed 2-pole tied together circuit breakers, 40 amp or 60, with a mechanical interlocking. And the second step is push the button to start your generator, and all your loads are up and running, nothing. You don't need to do anything else.
You said we wanted a non-separately drive system,
Yes.
so it could share the neutral and the
Yes,
ground.
yes, yes. Okay, guys, this is most residential, the most common application for residential. Another application, if you if you have the money, look what they did now. Now, if you have the money, this is more into, you can't do that with auto. This is more auto transfer switch, guys. I have a sub panel here. I have the main panel, I have a sub panel, I have a generator and auto transfer switch. Instead of having these mechanical interlocking, guys, now they have a full spiel auto transfer switch or manual transfer switch. You could buy a manual transfer switch with one move. You shift it, you shift from the utility into the generator, auto or manual or static. So look what they did here. In between the sub panel and the main panel, they introduced an auto transfer switch. So normally, guys, if you look at the power, normally the auto transfer switch or the manual switch, it could be manual or auto. Look at how it's connected to the utility side. So here's my 60 amp here coming through an auto transfer switch, feeding this sub panel. The system right now, the way the system is looking, this system right now is a normal system. This is sub panel. A sub panel fit from a panel. Do you guys have an issue with that? Sub panel fit from a panel. No problem. Up the way it shows right now, sub panel fit from a panel. Now, I don't think I have it. Now, if you have an emergency, and I'm going to ask you guys, is this a separately derived system or non-separately derived system? Look at it now. Look at the way it is. Is this a separately derived system or non-separately derived system? Separately derived system or non-separately derived system? Am I bonding the neutral and the ground here? No. So this is a non-separately derived system. Am I bonding the neutral and the ground? Can I make it, Spencer, a separately derived system? Bring it on. Two things you need to do. First, bond these two together here. Second, you have to buy, if this is a single phase, you need to have 2-pole transfer switch. One pole for phase A or hot A, the second pole for hot B. If you want to transfer a switch, you need a third pole so you can switch the neutral too. You're going to hear, guys, 2-pole transfer switch, 3-pole transfer switch, 4-pole transfer switch. In a 3-phase, if you have a separately derived system, you hear them talk about 4-pole transfer switch. Pole 1 is going to transfer phase A, phase B, phase C, and a neutral. So what does that mean? Mean your auto transfer switch is bendy if you are a separately derived system. Your auto transfer switch is bendy if you have a separately derived system. You have to have 4-pole. If you are a non-separately derived system, the only thing I need to do is to transfer the 3 phases or the 2 hots in a single phase. Okay, does that make sense? So in a case like this, this is a non-separately derived system. Non-separately derived system. Why it's a non-separately derived system? If you guys look right here, no bonding, neutral and ground. No bonding, neutral and ground. So based on this is a single phase. Based on this, didn't see if it's a 2-pole Did they continue to do a two-pole here transfer switch? They're not saying it's a single phase utility. Say let's assume this is single phase, guys. Then looking at this, how many poles? Two-pole transfer switch. Why do I have two-pole transfer switch if it's single phase? Why do I have, guys, two-pole transfer switch if it's single phase? Because I'm transferring only phase A and phase B, or hot A and hot B, or hot 1, hot 2. Because it's a non-separately derived system. To make this a separately derived system, Mr. Bew, you need to add a third pole here, and you need to go here and what? Bond the neutral and the ground. You can bond the neutral and ground in two locations, Brooks. You can bond the neutral and ground right at the transformer, at the generator right here, or you can bond the neutral and the ground right at the sub panel. The reason, guys, why, any question about that? Any question about this system? So this is your next step system. I will bring to your attention, guys, as in a system like this, I will bring to your attention that the grounding electrode conductor right here, grounding electrode conductor is sized here, and it's also the same grounding electrode conductor works for the generator because it's non-separately derived system. If it was a separately derived system, I have to bring a grounding electrode conductor from here down to Mother Earth. Okay, so, and you have to bond here. Can you guys see how this is the neutral and the ground are bonded at the surface? That you have to must. But here, no, because it's non-separately derived system. The last thing I want to bring to your attention, guys, here is the control wire. Can you guys see that the control wire? There's these dotted lines. These are control wire right in here. These are control wire. The auto transfer switch, you have to bring wires from the auto transfer switch to the generator, because when you lose power, you don't want to go there and manually transfer this auto transfer switch. The auto transfer switch, when the power, it senses that the power here is lost. When it senses that there's no voltage here, it sends a signal to the generator to start. The governor of the generator receives a signal, start the engine. The engine starts, come up to speed within 10 seconds so if it's an emergency system, or 60 seconds, or whenever if it's non-separately derived system. So this installation, guys, could be separately derived system, could be emergency system, legally required system, or standby system, right? And I can have it separately derived system or non-separately derived system, either way.
What would happen if you just, if you bonded both sides of them and put a GEC on both of them? Would it be extra safety, or?
If you bond both of them, then you're violating the code, because the code says you only bond the neutral and the ground of the source. Long story short, this panel now, if you bond them again, the neutral, do you see that conduit here? If you bond here and here, when we're running normal, under normal condition, that conduit will be carrying current. The conduit will be carrying current, right? Because you bond the neutral and the ground here, and you have a neutral current coming back. Some of it will go through the neutral, no problem. The other part will go through the conduit, if it's EMT conduit, and that's violation of the code, because equipment grounding conductor must not carry current. Why? Because if you go accidentally, first of all, these are not meant to carry current, they'll arc. And second, if you are to open that conduit, you're going to get zapped. Any question, guys, about this? Yes, sir.
I've worked on real big ones, but I can't remember. What would be your reason to make that a separation from a non-separation? I can't remember how we did it, because it's been like 6 years. But I mean, they're big, like huge,
Yeah.
like semi-trailer.
Yeah. When you get into a major equipment, it's always separately derived system. For the major, yeah, separately derived system.
Okay.
The reason for that one, guys, because you have multiple 2 meg generators here. You don't want these 2 meg generators to depend on the grounding, the electrode grounding system of the service. You want to completely isolate the building from the grid,
Okay, no, that makes sense. Because I was thinking that's how we did it, but it's been a while.
Separately derived system.
Okay.
I will bring to your attention, guys, if it's a generator, Anybody remember the ones who were in my class? You need a disconnect for the generator within sight of the building. You guys remember there's an exception that they created in 2011 that if this building is under certain management and blah, 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 and only qualified people handle it, you don't have to have this disconnect within sight of the building. Well, you need but the best thing is to have it. So we have a disconnect over here for the generator. Remember, you have to have a disconnect for the generator. And I want to bring to your attention, guys, an overcurrent protection device right in here. Why overcurrent protection device? Because you want to protect the feeders. You want to protect the feeders. Why disconnect? Isolate completely the system. Could this and this be in one? Could the disconnect and the circuit breaker be one? No problem. If you can lock this disconnect in the open position, no problem. Any question, guys, about that? When it comes to generator, guys, next quarter, we bring Cummins. We do two things. We go tour Cummins, and you see a lot of separated drive system and paralleling and so forth. And we also bring Kohler to talk about generators. How do you size generators, the difference between diesel generator versus natural gas generators, and all the mechanical part of the project. We really, the guy who comes, Mr. Boggs, does really good job explaining the system. Not the electrical part, but mainly the mechanical part. Any question, guys? Any question? So that's my separated drive system, or non-separated drive system, depending, in this case is a non-separated drive system. Just FYI, guys, when you lose the power, this is where the auto transfer switch will sense that the voltage right at this point. Auto transfer switch, guys, will sense, the sensor senses that there's no voltage here, and it has, of course, an electronic brain. It will send the signal through these control wires to the governor of this generator and start the diesel engine generator. When the diesel engine generator starts, it rotates, obviously, and start the generating power. But the key point is the auto transfer switch, guys, is a smart piece of equipment. It has the capability of sensing there is no voltage here. There's sensors, voltage sensors. The minute that you have no voltage here, it's programmed to send the signal directly. It has a battery backup. It has a battery. How it's going to sense if there is no power? There's a battery backup on it, and it sends the signal to the generator to start. That's if you have an auto transfer switch. Auto transfer switch. If you decided to have a manual, Mr. Bew, you can have a manual transfer switch, right? No problem. If this is a manual transfer switch, you lose the power, you're dead. So you have to walk, DJ, knowing how you walk fast. You have to walk and go outside, push the button for this generator to start it, and go inside and throw this transfer switch to the generator side, and now you're energized. Is that okay? Yes. If this system, guys, if this is a legally required system, can I have a manual? If this is a legally required system, can I have a manual transfer switch?
No.
No. If it's an emergency system, can I have a manual transfer switch? No. You don't want to depend on people's finishing their coffee to go start your emergency light.
We pay somebody full time to sit there and.
It's not required. If it's optional system, like in your house, optional system, can I have this transfer switch, a manual transfer switch? Yes, that's the most common one. Manual transfer switch, cheap. What's the difference? Cheap. Manual transfer switch, dumb switch. You just shut it, throw it this way, and you go to the utility and walk. Spencer, when you have time, you go walk and you push the button on this generator. Now your generator is running, and your transfer switch is off. If you're not home, and you lose power, you're going to wait no power until you go home. That's a disadvantage of that one. If you have an auto transfer switch, if you're home or not home, your auto transfer switch will sense the power is off and go start your generator right away. Any question, guys, about this system? Separated drive system. And in this case, this is a non-separated drive system. Okay. So basically, I will leave it here, and I'm gonna remind you guys as we go next quarter. We're gonna go in depth. Basically, we're gonna forget about that little deal here that we did. You're gonna forget about this, and we're gonna go directly into the separated derived and non-separated derived system. We're gonna be working with system this way. Any question, guys? Any questions? So to have a generator, you can have it. The cheapest way is to have a generator, portable generator, plug and with plugs, and you plug in one load at a time. That's the cheapest one. The second step is to have a generator portable with a cable. You plug the cable like we did. Plug a cable, guys, directly into. You plug a cable directly into an outlet, and then you start the generator with this mechanical airlock. That's the next step. The best, most performing part is to have. This is not a portable generator. Can you guys? Another thing I mentioned I forgot to mention. This is not a portable generator. Can you guys say that? This is standalone generator. Sit on a concrete pad. Now with this application, the best application for this is to have an auto or manual. It could be auto or manual. Auto transfer switch. So this guy could be an auto transfer switch. It could be manual transfer switch. Especially since we're talking about residential, manual transfer switch is the most common because auto will cost you an arm and leg. These switches, guys, like any other switch, you can get them from probably from 30 amps all the way to 3,000 amps.
How much would like an auto one cost versus manual? You have any idea?
Auto for the same amps, the same voltage, you're probably double. For the same amp, the same voltage, 30 amp auto transfer switch versus auto versus 30 amp disconnect, you're probably talking about double because of the electronics involved in it.
It's really expensive ones, right? They're pretty fast.
Yeah, that's auto. There's static ones.
I think when I was looking them up, I remember if you run a machine on it, they're so fast that the machine won't be able to tell.
Thank you.
That
The next step, I didn't want to mention it. The next step, guys, for certain loads only, they have what they call a static. What you're talking about is static transfer switch. Static transfer switch, Mr. Bew, since you mentioned it, it will transfer within a quarter of a cycle that your eye and my eye will not be able to see any interruption in the power. They use it a lot with electronics equipment. It's not required for emergency system. Static transfer switch transfer within half a cycle or a quarter of a cycle. So you can't, when it transfers, you guys cannot, it's fast enough that you can't see the light off. An auto transfer switch, you'll see the light went off, flipped in the system, and it came back. You will see that. So if you have a clock or something, you have to reset your clocks. Yeah.
A 30 amp.
My experience with them, Mr. Bew, STS is for electronic equipment.
Well,
I don't know what you guys did there.
at 3M,
At 3M, yeah.
other machines, because their downtime is not, they don't want any.
They're very expensive. Yep.
Yeah, so I just remember that they were so fast you couldn't tell.
You can't tell. Yep, that's static transfer switches. They transfer
I
electronically.
don't know how much they cost, but it's probably more than I'll ever see in my life.
Yeah, expensive.
So a 30 amp transfer generator, 30 amp on this 158 for a manual.
How much?
158.
158
Yeah.
manual. Can you check an auto?
Yeah.
Check the auto.
That's $158.
158, right?
That's very cheap.
Any question, guys, about this? Any question? Transfer switches. The last thing I want to do, guys, I will mention two things. Generators, we'll talk about guys in details about them. Permits. Generators are EPA regulated animals, so you have to regulate them through EPA, and you give it to a whole lot of animals when you get to commercial. The second thing, guys, is the sound, the noise, and we will talk about this one as we go to the commercial. They're rated based on how quiet they are. There's measurement on the decibels that they allow you to go to the property line. So I want you to leave these two topics, the sound, the noise coming out of generators, and the EPA requirements until the commercial industrial. Because in residential, no problem. These are guys, you're talking about 5 to 10 kW. These generators ranges from 5 to 10 kW. Small generators, 12.5, sometimes you get them. Small generators, they don't get into a whole lot of regulations for them. You get higher than that, you get into EPA requirements and regulations and how long you can do them and all this good stuff. So we're not going to get into that one today.
They got some for $84 and some up to $230.
Transfer? Auto? Okay. The last thing I want to do, guys, okay. The last thing I want to do, if you have a generator, we have a gen. Let's say my generator is 200 kVA. If I have a generator, guys, 200 kVA, if I have a generator 200 kVA, and I need to size the overcurrent protection device and the conductors for the generator. That's the last thing I want to do. I have a 200 kVA generator, and I need, and the voltage, since we're residential, we're going to go 240 volt, single phase. I have a 200 kVA generator, 240 single phase, and I need to size two things. I need to size for this generator the conductors, number one, and number two, of course, always as the overcurrent protection device, number two. Okay? The conductors and the overcurrent protection device, guys, for this generator. And then we'll 424, 430, 430, 440, 450, 445. Okay, if you guys go to Article 445, Article 445, and we're going to size the generator, ambiguity of conductors, disconnect means, and so forth. You're going to find a chart. Yes, sir. You have. Oh, you okay. If you guys go to Article 445, the conductor. If you read through Article 445.13 from 445.13. You're going to find that the conductor, we size the conductor based on 1.15 times I. But since I don't have the I, the first thing I need to do, guys, the first thing I need to do is find the full load current of this generator. How do you find the full load current of the generator? I equal 200K divided by 240. What's the amp, Holly?
833.
How much?
833.
833 amps. 833 amps. So I have my full load current of this generator. That's easy, straightforward. Find the full load current of a generator at 240. If you know the KVA. Article 445. 445.
13.
Yeah, the conductors. So the feeders or conductors. So if you guys then you're going to take 1.15 times what's 833 amps. What do you guys get? You multiply it by 1. How much? 958 amps. Any question, guys, about this? 958 amps. 958 amps. 958 amps. And then straightforward, right? You find the full load current of the load, you multiply it by 1.15. And then from here, can I carry this with one conductor? It'll be tough. So let's divide it by 2. Take 958, divide by 2. What would that give you? 479 amps. And from here, my friends, you're going to take 479 amps, take it to where? 310.16. We still 310.16 on the 75-degree column. What do you get? 800. How many sets? We have 2 sets of How many conductors? Let's just full neutral. 3 conductors, 800 kcm. Okay, guys. So we size our conductor based on 1.15 for this generator. So you take the full load current of the generator, multiply it by 1.15, and then because this is a huge current, unless you want to carry a bus ducts or busways, you're going to divide it by 2 or 3 even, and you're going to end up with 2 sets of 3 conductors, 800 kcm each.
That's all you have to do. You don't have to account for like bushings and all that other stuff, or
Bushings.
I think when we're doing something like that.
Are you still thinking of taking off maybe? Bushings as in doing a takeoff?
I'll look through my notes. Well, I think it was something to do with motors and whatever.
We already sized this generator. The generator, we added all the loads. We sized it based on starting current and inrush current, starting load and running load. And now this is the running load. Based on the running load, we came up with 200 kcm. We're just going to size the conductor. We're going to size the conductor. Any question, guys? Holly, how much current can 800 amp carry? 490. Okay, so we have enough room in that one. Okay, any question, guys, about the conductor? Full load amp times 1.15. Done. We parallel just because it's too big. Had this been a 20 kW, you don't have to do anything. You just go all the way. Now for the overcurrent protection device, this is how I do it. And if you guys look at the code, it's not clear how you do it. So number 2, for the overcurrent protection device, I do the same. Overcurrent protection device. I use 1.15 times, what was the current again?
470.
No, before you multiply it by 1. Okay, no big deal. You multiply it by 833. Multiply by 833 amp, and you get with 9 something. You get to multiply 958 amps. Okay, the same calculation, guys. Then you take the 958 amps, take it to where? 240.6. What do you get? Go up if it's not a standard. 1,000 amp. 1,000 amp. 1,000 amp. Go up 1,000 amp. The only test that I do, guys, all the time, can the conductors that we have handle 1,000 amp? Can the conductors that we tied handle 1,000 amp? So we had an 800 kcm, Holly from 310.16. What was the 960? 96. No, that's too big.
490.
490, that's what I thought. 490. Multiply this by 2, guys, because we have 2 of them.
980.
980 amps. The only test that I would do is now my conductors are rated for 980 and my overcurrent protection device is rated for 1,000. Then you have 2 options. Remember the 800 rule? Based on 800 rule, my overcurrent protection device can be slightly higher than my conductor. My conductors are rated, both of them are for 980. My overcurrent protection device is 1,000. You have 2 options. Either you go up this conductor to 1,000 or lower the overcurrent protection device to handle it. Up your conductors to 1,000 or lower the overcurrent protection device to handle this. So that's your option, is to up. So in a case like this, if I decided to go down, what would that be, the down on that one? 800. 800 amp. It goes to 800 amp. Any question, guys? when you do your calculation, the only thing you need to go check, can the conductors handle, when I add them up, can they handle the overcurrent protection device, because you're protecting conductors? Can the overcurrent protection device, is the overcurrent protection device higher than the conductors? Yes. Had this situation been 800 amp or less, no problem. Had this been 700 amp and this 650, no problem. Stay where you are. But because we exceeded, guys, because we exceeded the 800, then it becomes you have to match the overcurrent protection device to the conductor, or the conductor have to be high in amps. So that's why a lot of people, guys, first when you go that high, a lot of us, what they do is first they size the overcurrent protection device. If you are higher than 800 amps, the best way to do it, if you're higher than 800 amps, is always do the overcurrent protection device and then go size your conductors to match it. If you're higher than 800 amps, if you're higher than 800 amps, higher than 800 amps. Any question, guys? The only thing I want to emphasize is that multiplier, which is 1.25. You can put here C as here disclaimer here. This is not from the code. The code doesn't tell you how high you go in that overcurrent protection device. In the overcurrent protection device, this one directly from the code, guys. This is directly the conductor or directly from the code. If you guys look at the overcurrent protection device, if you just look at this article, 445.12a, 445.12a, if you go read it for the overcurrent protection device, it says constant voltage generator, except AC generator exciters, shall be protected from overload by inherent design, circuit breakers, fuses, protective relays, or other identified overcurrent protection device suitable for the condition of the use. Doesn't tell you how high you can go, and if you guys read through it, it doesn't tell you how to size it. But we size based on the overcurrent protection device, the conductor. And the reason why this, Spencer, because the generator has its own overload protection by manufacturer. So I'm not protecting this circuit breaker, because it's not to protect the generator. Generators have over voltage, under voltage, people, tons and tons of protection right in the control of the generator. I'm not worried about the generator. I'm worried about my conductors. That's why we do that. Generator, we're not protecting generator. Generator is protected by tons of relays, part of the construction of the generator, the controller for it. I'm only protecting my cables. I'm only protecting my cables here. That's why I said you're going to go back and check yourself, because this overcurrent protection device is really only to protect your cables. Generator has its own overload protection, frequency, under, over, tons of protection. It tweak it that if the frequency goes from 60 to 55, the generator will shut down. A good generator. Now we're talking about high, even almost any generator, they sit with the controller. If the voltage, it's a 480, and you overloaded the motor and the voltage went from 480 to 460, or maybe 440, down to 440, it will shut down. If the overcurrent protection device that's supposed to come out of this generator, like in my case, if you have an 853 amps and you pulled 900 amps out of this generator, the circuit breaker will not even wake up. It wouldn't even wake up. The controller of the generator will shut down. So I want you to understand what we're doing here has nothing to do with the protecting of the generator. The generator has its own full spiel protection that comes with it. Overload, over frequency, short circuit protection, everything is right with the generator. The only thing that we're protecting is our cables for this overcurrent protection device. That's why I size the overcurrent protection device to the cable, and so forth. This is by code, you have to do that. Overcurrent protection device can be any value you want as long as you protect the cables. Any question, guys? Any question? Yes, Mr. Abel. Go to the second one.
Yeah.
This one.
What is the number 2 you divide by 490?
What is number? I'm sorry.
You divide 490 by 2. 490.
We did that one in the first one. Yeah, we did it in the first slide. You mean
No, it was something like that.
Wait,
Sorry, you multiply it, I mean.
oh, you multiply or divide? Okay, it's all right. You multiplied by 2 because we have 2 sets, Mr. Abel. We brought 2 sets of 3 conductors. Each one of them is an 800 kcm. We brought to this generator. Why? Because we parallel. Why did I multiply by 2? Because I parallel 2 sets. If I parallel 3 sets, that would be multiplied by what? 3. But I need to test, is the overcurrent protection device capable of protecting my conductors? In this case, no. So I went down. You can go down or up, no problem. Or if I don't want to go down to 800 amp, I could have went to a higher. What's the next is 900. I would go for 2 sets 900. 2 sets 900. I'm sorry, Mr. View, is it too big or too?
No, I just haven't listened to the code, but 800 seems pretty big.
Did you look at the voltage though? The voltage is 240 single phase. Maybe you're thinking of 480, 277. Yeah, it is single phase. Yes, it's a huge. You wouldn't find it at this voltage, guys. So, yeah, you're exceeding. Yeah, it's a 240, 200 kVA. You're not going to find it at this voltage. Yeah. Any question, guys? That's really all what I want from this chapter. Any question? If you guys don't have any questions, that's all I have for you. No? Mr. Rivera? No?
So
I got a
review after
Review?
tests or no?
We did Friday.
Were you here Friday?
Yeah, I thought you said, I thought you said you were reviewing Monday.